Good morning, dear students. Welcome back to physics class. In today's class, I would like to discuss on two topics. They are A. Viscosity and B. Stokes law. In previous class session, I had pointed out one important characteristic of fluid, which is viscosity. What is viscosity? It is the property of a fluid that resists the force tending to cause the fluid to flow. You know that different layers of fluid flow with different velocities while a fluid flows. These layers exert frictional forces on each other, resulting in a loss of energy. This property of the fluid is called viscosity. For example, consider two glasses, one filled with water and other filled with honey. You can notice that water can flow down the glass very rapidly, whereas honey cannot. This is because honey is more viscous than water. Therefore, in order to make honey flow, we need to apply greater amount of force because honey has the property to resist its motion. Viscosity comes into play where there is relative motion between the layers of the fluid. The different layers are not moving at the same pace. It is analogous to friction in solids, which means that it can be comparable with the friction in solid substances. Now, I am going to give you a concept coefficient of viscosity. For any layers of liquid, its upper layer pulls it forward while lower layer pulls it backward. This results in force between the layers. This type of flow is known as laminar. The layers of liquid slide over one another as the pages of the book do when we press the top cover of a book placed on a table by a horizontal force. Consider a liquid flowing in a pipe or a tube. The velocity of the fluid layer along the axis of the tube is maximum and the velocity decreases gradually as we go towards the wall where its value becomes 0. Let ABCD be the shape of a portion of liquid on account of this motion at some instant of time, and let AEFD be the shape of the liquid portion after short interval of time delta t. During this time interval, the liquid has undergone a shear strain of delta x by L, which is shown in given figure. Then, what is the coefficient of viscosity? It is the measure of degree to which a fluid resists flow under an applied force. This means that how much resistance does a fluid have to its motion. It is the ratio of shearing stress to the strain rate, which is denoted by eta. How can express the coefficient of viscosity mathematically? We know that it is the ratio of shearing stress to the strain rate. Then, let F by A be the shearing stress and delta X by L be the shearing strain. Then, what is the strain rate? It will be delta X by L by delta T is equal to delta x by L delta t. Then the coefficient of viscosity eta is equal to F by A by delta x by L delta t, which is equal to Fl divided by A delta x by delta t. Since delta x by delta t is equal to v, where v be the velocity, it is the rate of displacement. Then the coefficient of viscosity eta is equal to Fl divided by Va. It is the mathematical expression for coefficient of viscosity. Coefficient of viscosity. Its unit is Poiseuille, which is shortly represented by Pi. 1 Pi is equal to 1 Pascal second or 1 Newton second meter raised to minus 2. It is understandable that Pascal second or Newton second meter raised to minus 2 are other units of coefficient of viscosity. Can you say if temperature depends on coefficient of viscosity of fluid? Definitely. It depends on coefficient of fluids. The viscosity of liquids decreases with temperature while it increases in case of gaseous substances. The following table gives the viscosities of some fluids. So, what is relative viscosity of a liquid? It is the ratio of viscosity of liquid to viscosity of water. For example, relative viscosity of blood is viscosity of blood divided by viscosity of water. It will be constant between 0 degree Celsius and 37 degree Celsius. Next topic I am going to discuss is Stokes' law. Consider a body falling through a fluid. When the body falls through the fluid, it pulls the layer of the fluid which is in contact with it. There is a relative motion between the different layers of the fluid. As a result, the body experiences a retarding force. For examples, falling of a raindrop, to and fro motion of pendulum bob, etc. During their motion, they track the layers of the fluid in contact with them. So, they experience the retarding force or decelerating force, which always oppose their motion. Then, what is viscous force? It is the retarding force experienced by the body when it is in relative motion with respect to the fluid. This force is proportional to the velocity of the object, but it is opposite to the direction of the motion of the object. This force is also known as viscous drag force. What are the other quantities on which this force depends? They are viscosity of the fluid and radius of the body which is in spherical shape. The English scientist Sir George G. Stokes derived an expression for the viscous force, which is F is equal to 6 pi eta Av, where eta be the viscosity of fluid, A be the radius of spherical shaped body, and V be its velocity. This is known as Stokes' law. You have to notice that Stokes' law is applicable only to laminar flow of liquids, but it is not applicable to turbulent flow. This law shows that retarding force is proportional to velocity. This law shows that retarding force is proportional to velocity. Consider a raindrop in air. It accelerates initially due to gravitational force. As its velocity increases, the retarding force also increases. There is another force experienced by the raindrop. What is that force? This force is upthrust or buoyant force. It is the force exerted by the air against the weight of the raindrop in upward direction, as the air is a fluid. Then, these two forces acted against the gravitational force are viscous force and buoyant force. Finally, when sum of these two forces, viscous force and buoyant force, becomes equal to force due to the gravity or the gravitational force, the net force experienced by the raindrop becomes zero. When the net force becomes zero, what should be the consequence? The consequence is that it descends with zero acceleration. That is, the spherical shaped raindrop then moves with a constant velocity. This velocity is called terminal velocity, which is represented by Vt. When the raindrop moves with a constant velocity, the expression for viscous drag force becomes as F is equal to 6 pi eta a Vt, which is the expression 1. Thus, in equilibrium, sum of viscous force and buoyant force is equal to gravitational force or force due to gravity. We know that buoyant force is equal to weight of the displaced air by the raindrop, which is in accordance with Archimedes' principle, which states that weight of the air displaced by the raindrop is equal to upthrust or buoyant force experienced by the raindrop. Since the raindrop is completely immersed in the fluid air, then weight of the displaced air is equal to its mass m into acceleration due to gravity g. Since mass is equal to volume into density, then weight of the displaced air is equal to volume into density into acceleration due to gravity. As volume of the displaced air and volume of the spherical raindrop are same, then volume of the displaced air is equal to 4 by 3 into pi a cube, where a be the radius of the spherical raindrop. When sum of viscous force and buoyant force is equal to the gravitational force in equilibrium, we can write the expression in the form of 6 pi eta a Vt plus 4 by 3 pi a cube sigma g is equal to 4 by 3 pi a cube rho g, which is the expression 2, where sigma be the density of the air and rho be the density of material of the raindrop. Then Vt is equal to 4 by 3 pi a cube into rho minus sigma into g whole divided by 6 pi eta a. So Vt is equal to 2a square rho minus sigma into g whole divided by 9 eta, which is the expression 4, where eta be the viscosity of the medium air. From the expression 4, it is seen that the terminal velocity Vt depends on the radius of the spherical raindrop. More clearly, it is directly proportional to the square of radius of the spherical raindrop, and also it is inversely proportional to the viscosity of the medium. Dear students, today's homework questions are given in this slide. Please, you have to work out these question answers by today itself. Okay, thank you. Have a nice day.